Hello and welcome to another video of mine. This video is mainly for a submission for one of my assignments, mainly for machine learning and and algorithms. But yeah, as of right now, this part here is to import all the libraries that are necessary for all the code to function. Then we have the dataset be read and display a header so that we know that one, it is being read, and two, have a overall general analysis of what to expect in the dataset. Then we have the info of each of the datas, so we know what kind of data type we are dealing with, and to check if there's any empty spaces in the data. Then I drops some of the columns as they either provide no sustainable prediction or they're just useless like custom ID. Total charges are also dropped here for this simple fact that it is labeled as an object, even though it is clearly a float value. And because it is labeled as an object and not as a float, I will be dropping it due to the fact that it won't be working in cohesion with the rest of the code. Anyway, after we have dropped them, we can then create numerical and categorical columns, have the overall mean values of the numerical values so that we know the spread of the values, and then we can have a histogram to know the actual spread of the data across, well, all of the entries. Then here we have a categorical data, which is more percentage based to know how much of each category is what. And then we have a appropriate graphs here to see how much of it is churned and how much is not. You can stop at any moment to have a more of a glimpse at the graphs. But overall, a consensus and a conclusion you can come up with is those that pay month to month and either have and don't bother with extra services tend to churn much more quickly or more easily, so to say. Then this heat map is here kind of useless due to the fact that there's only really two used numerical values. If there were more, this heat map would be more useful, but this is more general to see how much 10-year and monthly charges are in relation. Then here we create dummy dummy variables, also splitting the data, transforming the data, and creating actual the metric function so that we know which is more of a confusion matrix, so that we have a actual test of, well, how well the models perform in predicting if a customer churned or not compared to the actual results. Anyway, on to logistic regression is up first. We first fit the data into a logistic regression model, and then we can see how it performs. With an overall accuracy of 80, being more or less 80%, as it's in decimals, I go 0 to 1, 80% is not a bad result. And the precision recall and F1 score are mainly used to compare other models. Anyway, next, and this was with training data. With the testing data, we can see that the results are very comparable, nigh identical. Mainly the accuracy is bang on the same, But the values do change slightly here and there. It's only a 1% change, but overall it remains consistent throughout. Then we print out the odds table to see how likely something is to happen for churned customers. And most of them are internet service or fiber optic, VR streaming movies, and that they are streaming TV. Those are the three main reasons for why customers are churning, and that is what LR predicts. Then we fit the data with other values, mainly with the training values, and we get this ROC AUC curve, of which with a value of 0.84 indicates that it is a good graph. Well, a good model. Now on to SVM. Fit the data, and then test the data. Here, 0.79, 79% on training data, 1% less than logistic regression. And on test data, 80%. But more values have been changed, either for better or for worse. But overall, the overall performance technically has dropped compared to logistic regression. Then we can print out the odds table. The odds are very much the same, with fiber optic, streaming movies, and streaming TV are being the main reasons. And of course, that is if they are streaming movies and TV. And then plotting the curve as with logistic regression. This part takes some time, as it is SVM. It takes a lot of time. And it's 0.83. Overall, SVM is slightly underperforming and slightly worse than logistic regression. Of course, if I'd had more time, hypertuning would have been done, and the results may have been different for both logistic regression and support vector machines. But due to time constraints, that has not happened, and these are the results that I am working with. Anyway, this is a clear indication that the code is working, and this code will be uploaded via a .html file onto Moodle. Anyway, this is it. Hope you enjoyed, and see you next time.